We want to examine this now very generic problem using the rate of change and a given point. And so the first thing we want to do is recognize what this rate of change means. And so again, this is change in output over the change in input. And so for every 9 units of right horizontal movement, there is a change of 2 downward vertical units. Okay, so now let's look at where we want to go. We want to find the output value when the input is 10. And so we're sitting at 3 right now. So we want to go to 10 from 3. So that means we're going to have 7 unit change in the input quantity. Keeping from the colors from above where the inputs are in blue and the outputs are going to be in green. I want to go back and change those so that we have the blue units here in terms of horizontal change. And now we want to look at the output change. And so the output change is based on however many units we moved horizontally. There's also this change vertically. And so if I'm going to move 7 units horizontally, I'm moving at a rate of -2/9 at this rate, and we end up with a -14/9 of a vertical unit change. So this means we're going to go down 14/9 units. So a little more than 1 unit down. And so our new output value is going to take where we went. Using this change, we have to change from that value is -4/19 plus a -7, because that's where we were at. That's a reference output. And that'll end up with us being at -8.5 repeating. And so if we want to write this in terms of an ordered pair, so this again is a point on the graph, we moved from that point at this rate so that we would end up at an input value of 10, and our output value is now at -8.5. If it helps, you could draw this out on a graph to see how that change is actually taking place. We also want to look at what is the ordered pair of the vertical intercept. And so one thing we have to remember here in terms of the vertical intercept is that the vertical intercept is always 0, some value. And so that means we need to end up at, we want to find the input value of 0. And again, if our input value is at 3, and we want to go to 0, so 0 minus 3, because we would have to go to the left to get to 0. So 0 minus 3 is -3 units of horizontal change. And then we're going to take this -3 units, and we're moving at a rate of -2/9. So again, we're going to move for every 9 units of movement horizontally, there is a 2 unit vertical drop. But since we're going backwards, we would go backwards, and this time we would go up, because instead of going right, we're going to the left. Instead of going down, we would go up. We're not going to go all full 9 units. We're only going to go 3 of those units, and so we end up at 2/3 of units changed. So again, we were at -7, and we are going to change that by a 2/3 unit, and so we end up with -6 1/3 units. And so now we know that the vertical intercept is 0. Oops. Let's do that in blue. Keep it as our input being blue, and our output now is negative 6 1/3. So we have a vertical intercept of 0, comma, negative 6 1/3. We have another point 10, comma, negative 8.5 repeating, and we also have a point 3, comma, negative 7, and this is all assuming that that rate is constant. So we actually have 3 points now with this rate of change every single time from each one of those points.